Hello everyone, welcome to the video lecture series on Advanced Separation Process. Myself Jaimin Pandya, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. So let's continue with the chapter number 2, which is a membrane separation process. In this lecture, we are going to discuss about synthesis of membrane and various methods for synthesis of membrane. In previous session, talk about the various method for synthesis of membrane such as the phase inversion method, trackage method, sol gel method, interfacial polymerization method, and melt pressing. So, phase inversion process is further classified as a thermal inversion method and solvent evaporation method. In phase inversion method, there is a mixture of the polymer and solvent where we are going from this single phase area to the two phase area. We are getting one solid phase of membrane and pores of the solvent, and that solvent will be evaporated by heating up it. So we will get porous membrane. So this is all about the phase inversion method. Phase inversion method is classified as a thermal inversion method and solvent evaporation method. In solvent inversion method, we are going to evaporate the solvent and get the porous membrane. Where in thermal inversion method, polymer solution is go to the casting roll and is converted into the polymer film, which go to the extraction bath, where polymer film is converted into the thin polymer film and is go for the drying purpose, and we can collect from the roll. So this is all about the thermal inversion process. Now let us discuss about next method, which is a trackage method. In trackage method, film are used and charged particles strike on this film. Due to that, the pores are made. These pores are cylindrical pores. So in first step, we are going to strike the charged particle or bombard the particle on the membrane surface, and so that we are get the pores, and this membrane is each into the each bath, so we will get the uniform membrane. So there is a two step in a trackage method. In first step, we are going to the strike the charged particle on membrane surface, and then it go to the each bath for the etching purpose, where we are getting the uniform pores. Then we have discussed about the sol gel peptization method. In sol gel peptization method, metal oxide are used, which peptidize, which means it's converted into the colloid particle. When peptidization of metal oxide occurs, is converted into the sol. This sol is mixed with the binder and make the viscous sol that pass from the filtration through microporous support, and gelation process start. In gelation process, these colloid particles are converted into the solid. After gelation process, sintering process occurs. In sintering process, we are going to merge this colloid particle and make the solid. Due to the merging of this solid particle, we will get some pores in a solid structure, and permeable membrane layer is formed. So this is all about the sol gel peptization method. Then after, we have discussed about interfacial polymerization method. In interfacial polymerization, aqueous chemical use and organic chemical or organic solution are used. Interface of both these solution, we are get the membrane, or can say that porous membrane. Then discuss about the melt pressing. In melt pressing, we are going to use the polymer pellet. This polymer pellet is passed through the hot plate and converted into the porous membrane. So these all methods are described in previous session. Now in this session, we are going to discuss about the film stretching method, template leaching method, and preparation of an exchange membrane. So let's first start with the film stretching method. In film stretching method is generally used for the small opening in dense film of the crystalline or semi-crystalline polymer like polytetrafluoroethylene or polypropylene. The film is first formed by the extrusion and stretching at temperature near the melting point of the polymer. It is a stretch again subsequently in direction perpendicular to the original stretching direction when very high number of silt like void or pore are formed. Membrane manufacture in this process are having very high porosity. such as 90% microporous hollow fiber membrane are also made by the similar technique. An STM photographic image of this PTFE membrane are shown in this image. So this is one hollow fiber membrane, and this SCM scanning electroscopic microscopic image of the cross section of this hollow fiber. This is a image for the outer diameter or outer wall of hollow fiber, and this SCM image for the inner diameter, or can say that inner wall of the hollow fiber. So in film stretching, the film are stretched using this equipment, and we will get the pores are rejected. So this is all about film stretching. Now let us discuss about template leaching. A homogeneous film is prepared from mixture of membrane matrix material, and leachable component is removed with suitable solvent and microporous membrane form. So what is basic difference between template leaching and phase inversion method? In template leaching, the template, or can say that solid particle, are used to form a pores, where in phase inversion method solvent are evaporated to form pores. In phase inversion method, uh, one phase of solid polymer and second phase of liquid solvent. So these pores are formed from the liquid solvent which evaporated and convert into the pores. Where in the template leaching, solid particle, or can say that template, are used to form pores. So this is basic difference between the template leaching and phase inversion method. In phase inversion method, pores are formed by evaporating the solvent, where in template leaching, a solid particle or template are removed and pore of membrane are formed. Template leaching is not widely used but offer a alternative manufacturing technique for insoluble polymer. A homogeneous film is prepared from mixture of the membrane matrix material, and leachable component is removed with the suitable solvent and microporous membrane is formed. The same general method is used for the preparing microporous glass. So this is all about the template leaching. Now let us discuss about the next method, which is a preparation of an exchange membrane. These membranes are mostly reinforced with backing material in order to maintain their mechanical strength. This membrane show excellent electrochemical property and high chemical stability in electrodialysis and electrolysis. An exchange membrane can have prepared by drafting of polymerization monomer to polymer film by the Ray irradiation. The film used are generally polyethylene, PTFE, polypropylene, polysulfone, and polyfluoroalcohol, while the acrylic acid is mainly used as a monomer. Trifluoroacrylate and styrene are used in some cases. In general, when an exchange membrane is made by this method, an exchange group are distributed heterogeneously across the membrane cross section. Another method is a direct introduction of cation or anion exchange group in conventional polymer such as a polyether sulfone, polyethyl oxide, polyvinyl chloride, and so on. The method to make the anion exchange membrane to be a anisotropic structure is to form high cross-link layer of anion exchange membrane over the porous vinyl fluoride membrane. The membrane made by this method is suitable for diffusion dialysis. Other kind of anion exchange membrane are obtained by subsequent sulfonation of film, of which conventional film has integrated by the styrene and divinyl benzene for the copolymerization, and casting the mixed solution of polystyrene sulfonic acid and other inner polymer, the latter case suitable for the preparation charge reverse osmosis membrane. In order to increase concentration of an exchange group of membrane, sometimes hydrophobic group are also introduced in membrane matrix. This method gives low diffusivity of salt and low osmosis of water to the membrane. Perfluorocarbon cation exchange membrane for alkali process has anisotropic structure in cross section of membrane, and cathode side of membrane has thin carboxyl acid group layer of a given ion exchange capacity, and anode side of the membrane has thick sulfonic acid group layer or carboxyl acid group layer of a high ion exchange capacity are provided. So this is about the ion exchange membrane. Ion exchange membrane can be formed by the grafting of ion into the membrane, and we can get the charge monomer and polymerization of this charge monomer, we will get the ion exchange membrane. Second method, which is a cross linking method or copolymerization method, are also used for the preparation of ion exchange membrane. So in this session we discuss about the film stretching method, template leaching method, and preparation of ion exchange membrane method. In film stretching method, we are going to stretch the membrane, so pores generated from that pores. Solvent can pass from that membrane and a larger molecule is rejected by the membrane. In template leaching, we are going to add some solid particle in solvent and leach out from the membrane. So it make pores on the membrane. Then discuss about the anion exchange membrane that prepare from grafting or copolymerization or cross-linking and various methods. So this is all about today's lecture. I am completing my lecture here. Thank you.